right, so don't miss me too much. But today, these are the expectations. While I am gone, I'm actually going to be in the building, so I'll probably stop by at some point throughout the period. But these are the things we are going to be doing. First of all, if you've not finished your quiz corrections, I'd like you to finish those up. So please make sure you have your tests. You're going to be working on K under the Unit 2 handouts. Make sure you have all your corrections done. You've done your reflections. Work through those things. That'd be awesome. After you're done with your quiz corrections, you're going to go down and address any incompletes that you have at this point. So you might have to hold off on this for a little bit till I come back, but try to get as far as you can in preparing yourself for each of those pieces. So once again, if you're on page 1 of your test, that's the part involving analyzing the velocity versus time graph. You're going to retake that portion of the test. You're also going to retake the word problems, which should be learning target 3. So if you have to retake those, it will be an actual retake test. If your CER, your claim evidence reasoning paragraph, needs to be rewritten, you're just going to rewrite that. You don't have to do any kind of a retake besides the rewrite. Make sure you've included a clear claim, and then you very specifically reference and explain why that claim is represented and accurate within the position versus time, and also, sorry about that, and also so within the position versus time, and also the velocity versus time graph. In addition, your full explanation of your correct answers for 2C, which is the ACT style questions, would be the expectation for the 2C makeup. If you haven't done your acceleration project, please work on that. Make sure you're ready to rock and roll on that front. That would be good. And lastly, if you are at that point, you're then going to be working on your free fall lab. So that's going to be the part that I'm going to explain today. So at this point, I'd like everyone to open up B. If you have not already done so, I know hour 6, you should already have done this, but hour 3, please open up B under the handouts folder within the Unit 3 test, or the Unit 3 portion of the Google Drive folder. So open up B Free Fall Lab. Our goal today, if you've not done so already, is to go into the lab and use a motion detector to be able to figure out what is going to be happening when it comes to the acceleration due to gravity. So you all have your spherical objects, and what we're going to do is take a little look at what that lab is going to look like. So let me pull up my iPad real quick. And what you'll see is that in this lab, we are going to be looking at this kind of concept of analyzing the motion of a ball falling using 2 different kinds of setups. So one setup is going to be a situation where there's a motion detector on the top and the ball is being dropped down. So think about what's happening to the ball as it's dropping down. What's happening to its velocity? Yes, exactly. Speeding up in the negative direction. And it starts with an initial velocity of 0. Starts from rest. Now the other setup is going to involve the detector on the bottom. You're going to have a detector actually in a cage on the ground, and you're going to be dropping balls down. Now, once again, when you drop your ball, please do not drop the medicine ball on this one. Drop only the soccer ball or kind of softer objects, softer balls. You're going to drop them down, and you're going to go and figure out how it's falling and what the rates are going to be. So now, what you'll do then is look at this, and normally I'd go through and have you make your predictions. Remember, your position versus time graph is going to look like this, a curve. It's going to start with a shallow slope and get more and more vertical. So in other words, it'll be speeding up in the negative by looking like that, looking curvy. Your VT graph is going to be starting from rest with an initial velocity of 0, and then going from slow to fast in the negative quadrant. And then your acceleration versus time graph is going to be a horizontal flat line, right? No jerks in physics, so it's going to be a flat line, horizontal, constant, negative acceleration. So with that in mind, I want to go and see if we can look at what this is going to look like in the lab. So you're going to go through, you're going to find your sensor, get to your lab station, get to the laptops. And once you drop the ball, it's going to look something like this. Or it should look something like this. If it doesn't, you want to keep redropping it. So take a look. You can see that there are different phases and different parts of motion. So what we want to do is figure out, where is my graph? In this case, my position versus time graph, representing an object that was falling. As you remember from what we looked at, this is a period in which it was going to be curvy. So if you look on your position versus time graph, it's curvy here. And this is going to be the region of the graph that we're interested in. So curvy. Now, why is it curving up? So curving up should be speeding up in this case because it's getting more vertical. The slope is getting more vertical. But the reason why it's curving up is because it's a positive direction of motion. And this would be because this particular graph came from a motion detector that was on the top. And as the ball was being dropped down, the motion detector interpreted that as being a positive direction. So anyway, we're finding this part of our graph, the curvy part. And what we're going to want to do is go to our little curve fit button, and we're going to want to select the curve portion, which is this quadratic part. So quadratic is for curvy. So for our best fit, we'll hit quadratic, hit OK, and we're going to want to write down this equation. So as you go around, this equation is actually going to be a quadratic. X equals AT squared plus BT plus C, and you're going to write these coefficients for each of those letters. So the A is going to go in here. This B part, nothing after this part. So you're just going to write down 5.065 or whatever your number is. Plug in your B, plug in your C. Now we're going to look at our VT graph. This is the part where it's liney. So a liney portion means we click on our linear fit. If you look at your linear fit, you'll see then that down here you have this information for a line. Once again, your slope represents your acceleration. So that's going to be the number you want to focus in on, since our goal is to figure out what is the acceleration of our graph. For our AT graph, our acceleration versus time graph, we're going to hit the mean button, which for you guys, it'll say stats, I think. It looks a little different on the Mac, but it's going to be something like that. And then you're going to go down, you're going to use the mean as your average or mean velocity. All right, so with that in mind, once you've done that, and once again, this is all part of the free fall lab. You're going to work through that piece. And then once you're done with that, you're going to go through and you're going to work on the physics of skydiving module. So if you're done with your free fall, then you move down to the physics of skydiving. That is going to be on Blackboard. You're going to go to Blackboard. You're going to select the free fall link or free fall unit. And then under physics of skydiving, you're going to go link by link, watching fun videos of skydiving experiences like my own, like the Felix one, you know, the Red Bull guy, the guy that went way up high in the air and then ended up falling down, and from really ridiculously high like locations above the earth. We're going to be analyzing those and watching those videos. So anyway, that's the plan. So take a look right now at this organization piece, this kind of breakdown of what you're going to do. Make a goal for what you're going to accomplish today. Work on that, stay focused, and my expectations are that you guys are on task, working hard, getting this done, getting your free fall lab done. If you don't know how to do it, ask the questions of your peers. You have people around you that have already gotten to most of these places, that have done well on the tests, that have done the free fall lab. Use them as a resource. Otherwise, have a great day, do great things, be kind to the sub. See you on Monday. 2 more days till Thanksgiving. We can do it. Woo!